This is what they originally started out making, all these things.
Hot 60 statics. So diamond finish. So it's bare metal, cosmetic machining. Next one along is the brushed silver. So it's precision grinding to give this silver brushed effect. Clear dipped anodized. And the third finish is a blue anodized in a honeycomb machine. So if you zoom in on the top, you'll see that honeycomb machining. Which is a new technique that's been perfected here as SME.
Oh. Honeycomb.
So that's the three finishes. This is machine honeycomb. So blue anodized is many hours of machining that's gone into this surface finish. So this is a sample of it. So entirely machined SME, of course, as you would expect. We're calling this honeycomb machine and the silver finish. So now the flagship turntable is it's a three-piece turntable now. We've separated the transformer. So the transformer completely separate, so it can be 1.5, 2 meters away from the power supply unit, the Tonearm and the motor. This finish we've been experimenting with. So this anodized colour, we call it that, because we've got two samples here, blue or silver. Right. Any colour is possible, of course. Yeah. But the aspect of the SME, new to SME, is this machining technique. So traditionally, an SME turntable would have a transformer incorporated inside the power supply unit. But for this high-end, super high-end audiophile quality, we wanted to separate the transformer. So that's a separate box. Matthews, you may want to pass that over to me and I'll show you that, please. Alistair, could you lean over and get the transformer box, please? So this is just a casing, but that is what's going to house purely just the transformer. As I say, traditionally it would be incorporated inside the PSU. At the level we're at, the sound quality, sound performance, we've separated. So Nemo connectors all around, from the turntable to the power supply unit to the transformer box. So that's how it would be connected up by the Nemo connectors. In terms of the case, in terms of the machine case, this was a one-piece billet, and that's the level of machining program that goes into this case.
So this is our PSU, and I can spin it around, rotate, zoom in. What we can also do is, if I was to remove the cover plate, we can have a look inside, which is exactly what I think you've seen outside on the bench. We can do another cool thing, which is we can do dynamic live sectioning. So just by pulling this, I can take a section of whatever I want, halfway through the feet, halfway through the control knob, and I can save that. So it's a very quick and powerful piece of software that we use extensively now, because at the design stage it literally saves us hours. Yeah. So once we're happy with a design, we probably go to the next development stage, which is we take it into a program called Solid Cam. So this is a simplified version for the purposes of a demo. This simulates the cutter, and if I was to press play, it would give me a rough simulation of what I've asked the software to do. Because we're not there yet with AI, where it basically does what I tell it to do. So we need a simulator to just to give us a visual. I can enhance the block to give us what the surface finishes would be, etc.
It's fine.
Yeah. So that's that. And so we can do some zooming in, and you can see that probably represents the tool path we've seen outside around this area. Mm-hmm. So once I'm happy with that, we can basically then choose to write the code. It knows what machine, or I know what machine I want this to go on. I have got the option of changing. So if I generate some
We're
code,
looking for an effective mass of round about 12.5, 12.9 grams. So it's relatively low. But the structural integrity of the polymer resin tube is far superior than a magnesium cone. Now the magnesium cone, as you know, we've all enjoyed for over 30 years, which is effectively the best sonic Tonearm tube in the world. So we've moved away from that, and we've quite cleverly calling this now the Series 5A. It's an advanced version of the Series 5.
so this is where you can see the smoother details. I can spin it around. So I think it's quite, it's a fabulous piece of software. And you can, if I was to show you, so you can just about see the trilobe with the loft effect all the way through. And from that, it's really simple. We can say make a drawing from parts, which is what the engineers on the shop floor will need. Choose my boundary, and I can literally drag it. I'll do left. It's all automatic, you see. So that's the basic workings of a isometric drawing. So it's a fabulous piece of software.
Yeah. Impervious to temperature changes. And
This has got one of the highest temperature range in this family of resins, yes.
and how does it compare to like the magnesium material in terms of temperature?
Oh, it's very good.
Yeah.
Yeah, very good. So this is the finish straight off of that tool that you're actually seeing. Very light as well. That's the prepared fillet. So the next stage would be to finish the machine this component. So this is an exact mirror image of this. So that would locate here. And what we would do, we would clamp in several locations and machine in between the clamps, move, and vice versa, move them along. That's such a well-defined fit. We can achieve a perfect alignment.
And then what happens to that?
So after that, this will go in the machine.
Oh, I see.
We'll machine the opposite face. So this basically, in crude terms, that Tonearm will be finished on lot 2. So then we'll go down to our 5-axis machine on our other site, and we'll do the central bore. And obviously it's got a subtle tri-lobe, which you can...
Can you tell me how long this arm has been in development?
Oh, I've personally been working on this arm for over 9 months.
Like a baby?
Yes.
Like your baby?
Lots and lots of investment time.
When it was finished and came out, did it hurt?
It was exciting. Yes. So, I mean, it's acoustically dead as well, this material. I mean, this has been hollowed out, but you know, this is a magnesium cast.
Right.
You know, and believe you me, even with the central bore, it stands the same.
Yeah.
Which we believe, with the tri-lobe and the density and the acoustic sort of dampening of it, we believe that's a combination that's hard to beat. In the country where we have multiple banks of Tonearms, we start in the morning, finish with top one, 5 maybe a day.
From the rear view, we've now incorporated phono plugs So no longer is the Tonearm now with an independent connector. It's straight into RCA outlets at the back, and then the power supply connection is via Limo. The motor, we've now gone from DC to AC. We've got new generation electronics, so the speed control accuracy is far superior than the current flagship, the Model 30. So the AC motor is housed in a brass housing, of course, for that mass, and it's isolated from the chassis. So it's dampened and spiked, and there's now 3 adjuster wheels, so it can be raised and leveled.
So this is the new motor housing build up on the base. 3 adjustment spikes that go on. There's rubber pads over there on the chassis.
That's brass.
Okay.
Brass.
The whole build up is aluminium for a consistent black anodised finish that we wanted. So, but there is some brass parts in turn on that. Obviously the weight issue as well. So it's a heavy beast.
So the motor housing is completely independent from the chassis. The upper chassis is completely independent from the base chassis. Whereas the Model 30, with its suspended suspension, was all in a vertical way. This is a vertical platform. We've now got vertical and horizontal. So we get the vertical damping, and we've got the lateral horizontal damping.
So this is the foot isolation system. So you have the main foot, which has been machined. Over there, as you see, then you have the silicone rubber on the spigots. So you push 3 of those into the foot then, they're all isolated then, all separate from the foot. What happens then? So basically the silicone then is all held within there, silicone rubber. And then you have the separate, which is the base of the foot, 5mm rubber O-ring. So that is totally separate from the foot. All it's attaching to is the 3 spigots within inside the silicone. This is then giving you the ventilation. Then it's on a 1mm pitch thread on the foot, which then has got a separate foot housing which is attached to the bottom of the lower anchor gallery. So you've got a very fine thread within there, which then obviously this is then solidly mounted to the lower chassis. So that is mounted to there. The foot then screws up into the lower chassis, and you've got the adjustment to set your height level off.
And you level the turntable using those.
You can use the effect, yeah. Then obviously you send the this is an inverted now upper anchor gallery. So this is internal now. This is the old system that you've seen with the bands and the gallery cover.
And now the bands are internally.
Internally.
So it's the same basic thing inside.
Same basic thing, yes, but it's internal inverted now. And you have the horizontal damping. So this is the horizontal cut, that's from underneath. The main column goes on top, then this is fitted to the gallery cover, so that's placed over the top. That will then be placed down, attached with 3 screws, then 3 screws around the side. So what you get is the damping then. This
This Model 60 cover and spacer, as you can see on the top chassis, this is fixed solidly to the top chassis then. So then, once everything's in place, this is all built, and then the complete top chassis is then in one movement just placed over the top of these, and the weight then plated down, and then it's all isolated so that the top chassis is floating. So that will be in place then. What you have then is you have the SME loose Allen kit, which goes down. Then if you notice the screw on the top of the belly, that then adjusts once that's fixed in place, you can adjust the band and distance with that. Because you might want to level off the chassis, obviously different weight, different parts of the turntable. Some adjustment you would be adjusting one another to get it level. So that's the build-up of the main slip.
Times 4.
Times 4, yeah. Times 4.
In addition to that, we've got, as you would imagine, a precision bearing, because that's what SME do, we're precision engineers. We've got a precision main bearing, and we've hydraulically dampened it with a dampening bath to take out any tiny aspect of resonance that is generated from the rotating mass of the platter and the bearing. Upper chassis and lower chassis are treated with the famous SME isodamp. We've gone one step better, whereas the Model 30 to the side, so it's the outgoing Flagship, the isodamp material is surface mounted on the bottom. We've brushed it off now, so we've put machine pockets in the upper and the lower, and we've done an isodamp insert rather than a flush mount. So cosmetically, it's been much improved.
This retains the platter from that turntable?
It's a direct transfer over, yes. There was nothing we could do, Michael, to improve on the Model 30 platter.
Heavy construction. As you spin it.
It's unbelievable. It's like the V8 of the Austin Martin.
So the weight and the balance characteristics, there was nothing to improve on. So we haven't reinvented the wheel, we've kept it works. The isodamp top surface, as we all know, is precision machined, and that contributes to the sound performance and the sound quality of the playing record. So meaning it's not just a disc bonded on the top, it's pocketed, it's bonded in, and it's got a scroll machine, which contributes to the sonic performance of the turntable. So there's a lot of change. The electronics are new generation electronics, of course, to monitor and control speed accuracy. So new generation electronics, this is now why I call it the most advanced SME turntable ever. So the black is brushed and the silver is brushed. So in finishes, diamond finish, brushed finish, honeycomb finish. And brushed comes in black or silver. In reality, each finish can be done in multiple combinations.
Obviously you go from brand new machines down here. You recognise the record clamp again. It's actually the same completed in one operation. The subscript comes up and picks up the parts and we can complete the job.
So this is our coordinate measuring machine, solid granite bed, fully motorised head, 6 tool probes, thermally compensated. The origin now.
2.
Now these are done manual at the moment, but we have got the facility that if we had multiple
3.
components we can do it automatically.
Now, does every machined chassis have to be put into this machine
It will be,
so that each one is checked for?
It will be, yes,
Wow.
certainly.
Element finished.
So now it knows its origin. And I'm just going to straighten the job within the software now. After this stage it'll be going automatic, so I can't stop it, I'm afraid.
Don't worry, I adapted. I have so many accidents, I learned.
And it moves very fast. So now it's going to check the level in a much larger area for larger accuracy.
And of course, all this had to be programmed by you.
Yes. All the programs written in-house.
So it shows up here pretty stupid, right? And then you have to teach it all this.
So it's leveled the plane. Now it's checking my origin accurately and creating an origin point.
And all the chassis you make it here?
Yes, yeah, yep, yep. All made in-house.
So now it knows its origin. And we're checking the longest edge now, so we're telling the software to align the part. And the next operation after this, it will be actually physically checking some features. So now it's going to check this bore not only for diameter, but circularity. And what we'll have soon are some bars turning up on the screen, green or red, in varying lengths. Green means intolerance, red means out tolerance, so it's an instant flag. We're checking 20 points because we want to know how sort of round the bore is, which is crucial to us.
This is the kind of detail that a consumer just doesn't think about anything like this.
Exactly, yes. But every one of the chassis, the sub-chassis, and most of the parts actually will go through the CMM program.
Wow. And before you had this, how did you do that?
We had a semi-automatic CMM, but not on this scale.
Not like this. Yeah.
No, not on this scale at all. So we'll have some bars. So these are the bars of tolerances. So those two mid-tolerance. That one's a little bit towards the bottom limit. That one's bottom limit. When I say these are 0.5 of a millimetre, our tolerance band. So just over 4/1000ths of an inch.
Wow.
And it's still within that.
And if something is out of range, you can still take this part back and fix it.
If it's material off, yes. If it's material on, then we'll have to have the design meeting, and if it's a critical feature,
I see.
we'll see at the end of the program. I've deliberately told the tolerance band is so small just to show you what's going to be developed at the end.
And so after you spend millions of dollars on this thing, you get a free
Yes, you do.
Mitu Toyo
Yes.
clock, digital clock. That's very cool.
I think it should be doing a tool change soon after this bore. So these are all bang on mid limits. I can't cheat the machine, so that's how it was. We can get full written printouts with unique identification numbers if we require. This is a tool change now, which is quite interesting. So it's going to pick another probe out the tree, which are just held by magnets. It's just checking that everything's all right with that probe. It's just going to align the probe, just check itself. And we're going to check a smaller hole. Obviously we've got a smaller ruby. So that's the position. Now we're going to check the diameter. And we're going to check the pitch between those two holes just to give you an idea.
It's digital in service of analog. That's what it is.
So now it's going to do a tool change to the probe number 1. And we're going to index over, and I'm going to check the front edge to the plane for squareness, which I've deliberately told the tolerance to be smaller than needed. So this will be indexing now. this will typically show up cutter wear, etc. And as you can see, it's 0.15 out of squareness, but I've deliberately lowered the tolerance band just to indicate what would typically show up if this part was out of tolerance.
So now what happens?
In that instance,
Yeah.
well, the tolerance band's deliberately small, so this
Okay.
is fully acceptable.
Yeah.
I just wanted to
You don't want to
highlight
show, so we
the
see.
visual that,
Okay.
that we get.
I'll put a still on my website showing that and tell them that you manufacture that.
Just zoom
Unless
in
you
on-
give me a turntable.
Zoom in on the 0.15 out of squareness. 0.006 of an inch.
We're making, whether it's for our own products or for engineering, everything has to measure up against a known drawing. So these are all items that are from engineering jobs. Obviously we can't discuss who they're for. They're mainly from medical applications or precision pump applications. It just demonstrates the ability of a lot of machines. This high precision machining that's out of one single block.
Wow.
In 2 operations?
2 operations that block's actually finished in on our 5-axis machine.
Can you tell us what that's for exactly?
It's for the medical industry.
But you don't.
It's a chamber of some sort.
Yeah.
That's all we know.
So we just put this out really so that you can all see the ability of the engineers and machines and the programming abilities.
So if any SME employees has a vintage car where the part isn't made anymore, can you just sort of, would you do
Kevin, the
that?
man to talk to on that.
Would you do that for them?
These are from, we do lots of engineering for other companies, okay? Mainly medical companies, but sometimes aerospace and things like that. These are from health applications. So we do quite a lot of work for those type of companies. So this is from a health application, this is from a pump, precision pump. They're not necessarily all in production right now, but they've been in production over the last few years. The big centrepiece is one of our main engineering jobs at the moment.
So first impressions count, and I'm sure you'll join me in that it's a very attractive looking turntable. It carries all of the SME DNA. So all of the learning from SME's audio story, which started in 1959 through ARA, but some of that know-how, that knowledge and experience is translated into this new product. But of course, many years have moved on and technological advancements are apparent. And SME's been busy investing not just in new machinery and equipment, but also know-how. So we've taken the best of the SME DNA and we've added to it with different skills, and the net result being the turntable we've got before you. So it's our new flagship turntable. So from the ground up, we've got a decoupled foot, so it's completely decoupled from the main chassis, isolated, multiple isolation points. The main chassis is treated, obviously, it's made out of aluminium. The upper chassis is independent from the main chassis, so that's suspended suspension, typical or classic SME suspension system. The former flagship model, Model 30, has a vertical suspended suspension, still exists, and we've added to it with horizontal suspension too. Precision bearing, as you would expect from SME, we're precision engineers, and it's hydraulically damped through a dampening bath at the bottom of the bearing housing. So resonance control is extreme. A real addition to the Model 60 is the Tonearm. Now again, making the best better, which is quite a challenge. That was presented to SME. The Series 5 Tonearm probably is still today the best Tonearm in the world. So to take that to another level, we've achieved through what we're calling the VA. So it's the Series 5 VA Advanced. The key advancement is in the Tonearm tube. So as we all know, the Series 5 Tonearm is magnesium, so it's a metal, it's lightweight, it's strong, and it's got all properties that are still widely used in Formula 1 and aerospace and SME. However, we've switched through research, engineering, development. We've come up with a new concept for a Tonearm tube. So it's a polymer resin. It's no longer a cone, it's a trilobe. So a trilobe is stronger than a cone, which means we can remove weight. So trilobe in design, polymer resin in construction, one piece entirely made by SME on our state-of-the-art machinery. So it's quite a jewel to add to the pure and key DNA of a classic SME turntable. So that's a very, very fast overview. The factory, we've got a couple of static demonstrations we get into a little bit more detail. But as a welcome to the model, we've achieved that. And before I finish and we can start listening to some music, power supply unit, independent transformer. So for all those audio files, we know having a separate transformer adds to the musicality, adds to the performance, adds to the sound quality. So we've detached the transformer now, and we've kept the power supply unit, which is doing all the monitoring and speed control as a single piece unit. New generation electronics, and that's quite a significant advancement for us too in new gen electronics. And we switched from DC motor to AC motor for speed accuracy and speed control. So it's quite a package. It's a huge amount of change and a massive step change from the Model 30. And I'm sure you'll agree, this is now a serious quality product. Multiple finishes, which we can see and explore over at the factory. So we've moved away from the classic DNA of SME's paint system, that textured paint, and we've gone now into metal finishing. So, the Model 60, guys.
Thank you. Beautiful.
Thank you.
So, Mr. Ekman, our guests from around the world, from Australia, America, across Europe, and a little bit more local around England too.
You're so welcome. Thank you so much.
Thank you.
Thank you very, very much.
It's a delight that we're all interested in the same kind of thing like music. It's a great pleasure always at all times. Thank you again, and I hope you have a very happy time listening and also to the future. Thank you.
Thank you.
Thank you.